This is Mr. Hubbard, and welcome to another video. This is to review for our test that we're having this Wednesday. This test is going to be on the kinds of things we've been looking at for the past 3 weeks or so. Mainly, it's going to be on constant velocity particles, which is what we did our lab on and what we've been doing a lot of the work on in the past couple of weeks. You'll notice that it's going to need a lot of understanding of graphing. If you understand how to read and write graphs, this will be a very easy test. If you do not, then that is, rather than trying to memorize any single problem, you may want to try and review how to write a graph and how to read a graph, because they're very important. Okay, on this video I'm going to go over the kinds of questions that are going to be on the test. This isn't necessarily the exact questions. As a matter of fact, these are open answer questions, open response. The test is going to have a lot of multiple choice. The numbers aren't necessarily going to be the same, but the kinds of questions are going to be very similar. So let's go ahead and take a look at some of these questions. First one here, it says, what is the velocity for the graph below? And on this velocity, we have a position here, and we have time here. Notice that's the first thing I ask you to look at. Position versus time. It's a graph, so it's a position versus time graph. So if you understand that on a position versus time graph, what kind of information can we get out of it? Well, these are the distances or the displacements that our object has. And at time, this time here, it's at 0. At this time here, it's up a little bit more at 20 centimeters. This time here, it's up a little bit more at 40 centimeters. Okay, well, all of that is well and good, but how do we figure out the velocity? Well, on the position, on these distances, we have these numbers, centimeters, centimeters, centimeters. Over here, we have seconds, 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 and we have a line. And remember, every line has a line equation, and probably the most important part of that line equation is the slope. And the slope is the rise over the run. So if we take a look right here, I can pick out a couple of places, like maybe right along here. There's 40 centimeters right there. Let me add in another arrow here. There's 60 centimeters. Those are convenient places, but I think the most convenient place is, let's go right back down here, and you'll notice that point that I'm pointing my arrow at now, that's at 0.1 seconds, and it looks like it's about 20 centimeters. I'll move that arrow here. The reason why that's an interesting point is because when you're figuring out the slope, and let me just insert a text box here, or actually, let me insert a text box here. So I'll, let's see, shapes right there. I'll go right here. The slope is our rise divided by our run, which, I'll just say that equals the slope. And it's always easiest if you figure out some easy points. Now, you might have heard of way back when it'd be like y2 minus y1 divided by x2 minus x1. But if you get to choose your points, why not choose points where either or both y1, our first point, right here, is 0. And that'll just leave me with this. y2 over x2. In other words, take this point where it's 20 centimeters at 0.1 seconds, and if you put that into your calculator, you'll see that it's 200 centimeters per second. Okay? This is our velocity. Our slope, I kind of skipped over this here, but remember, position versus time. If you take the slope, then that slope is your distance, in this case centimeters, over your time, which is seconds, and you get centimeters per second, and that's a velocity. So if you can handle this kind of question, there's going to be a couple of them like this on the test. Others on this review that show up just like this, I'll go ahead and skip them very quickly. This one here, the slope of a position versus time graph shown below is equal to the, well, guess what? If you knew how to answer this one, you know how to answer this one. Slope of a position versus time graph is equal to the velocity. Here's another position versus time graph. Oh, this question doesn't need it. Which of these quantities is a vector? Okay, this was a multiple choice, and I deleted some of the choices. But we've talked about things that are vectors and which ones are scalars. The easiest two to remember: velocity, speed. One of these is a vector, one's a scalar. The easiest way to remember these is that vector starts with a V, speed starts with an S, and that gives us velocity is a vector, speed is a scalar. That doesn't work so well with displacement and distance. They both start with D's. But remember, distance is the one we're kind of used to using, and whenever we talk about a distance, we almost never talk about in which direction we're going. How big is that? How long is that? How far away? Those are phrases that we use when we talk about distance. Displacement is a new term. It's one of the terms we had to learn for this unit. And it is, the way we can remember it is that it's just like distance, but it's an extra funny name, so it probably has some extra funny stuff with it. And that extra funny stuff is the direction. So displacement is our vector. Distance is our scalar. There's other things that are scalars that we didn't talk too much about, but if you never need to know what direction it's going in, it's going to be a scalar. A young boy starting from a position 20 meters west walks 250 meters due west and then turns and walks 50 meters due east. Now, this is the kind of thing where we really need to draw a picture. I tried to show you this in class the other day. So if I'm going to insert some more arrows here. Insert I'll insert shapes. Insert this shape here. So we'll start at a certain point. Then he's going to walk 250 meters due west. Now this isn't going to be exactly to scale, but then he's going to walk back east. Copy. We'll paste this. Okay. So he's going 250 meters west. He's going to go back and go due east, but not quite as much. So this is where he's going east. And he started off, maybe I'll give an X marks the spot up here. I just move that over. This is where he started off. 20 meters west. He walks farther west, then he turns out and walks due east. Now, I know at this particular point, some of you will be saying, oh, wait a second, your arrows are pointing east, not west. When it comes to direction, you pick a convenient point for your directions to be in. They don't give us a picture. You draw your picture your own way. The whole point is if I remember that I'm going west when I'm over here, let's just say west. Let's see, right here. I'll say west. And then I'm going to do a little tricky thing. I'll paste another arrow so that we remember this. West is that way. So if we started 20 meters here, we add another 250 meters due west, then walks 50 meters due east. It doesn't say he showed up. He went to the 50 meters due east point. He's saying he's just walking 50 meters. So he went 250 meters this way, back 50 meters, so he essentially went 200 meters west from where he started. That is his displacement, his change in position, 200 meters west. How far did the car travel if it is moving 120 kilometers per hour for 3.5 hours? There's two ways to do this, and they're very, one of them is actually a little bit sneaky. And if you follow the units, it makes it a lot easier than you might think. I'm going to throw in an equation here. Actually, I'm not going to do it using that. But I'm going to use another tool here in just a second. And then I'm going to, oh, wait a second, here's my equation. I can use that right there. I'll come back to this in a second. So, how far did 120 kilometers per hour for 3.5 hours? So let's go ahead and type in 120, and go up here for the occasion, and I'm going to put in the units. It's going to be a fraction, and up at the top it's kilometers. This is the way they told us it was, km, and on the bottom it's hours. And they said it's 3.5 hours. Now, I'm not really trying to say anything here, but if I say 3.5 and I'm going to put in hours, well, that's actually kind of a fraction, so I'm going to insert another fraction. I'll do this one. Hours is on the top, just the number 1 is on the bottom. You'll notice that as I write it this way, I got lucky. I could have tried it a divided by, and that wouldn't have worked. But because I'm multiplying, you notice that hours here is in the bottom. I'll kind of highlight that. Hours here is in the top. I'll highlight that. They cancel out. So I did choose a right formula, 120 times 3.5. For the test, I will have a formula sheet for you. Don't worry about that. But this is something that you can figure out. This kilometers per hour, the hour is in the bottom, this hour is in the top. They should be multiplied together in order to get rid of the hours and leave you with just kilometers. So that ends up being 120 times 3.5. You can plug that into a calculator to figure out what that number is. Here's another one. This, you got to be careful of. We haven't spent a lot of time with this graph, but if you do what I asked you to do, look at the graph. This says velocity, this says time. That means this is a changing velocity. This is not a constant velocity. Before I even read the question, I made a note of what this is doing. It's a changing velocity. It's a smoothly changing velocity. This is a uniform velocity change, but it's still a change in velocity. It says, what does the graph indicate about the car's motion? And for right now, it's a changing velocity. I did use the word the other day. That word that we're using for this is acceleration. Here's another graph, and again, take a look at this. It's velocity versus time. We have to look at the graph. You can't just sit there and say, I've seen this before, I know what it is. Look at the words here, velocity versus time. Where on the graph below does the car have negative acceleration? Well, our changing velocity is our acceleration. That change is actually the slope of these lines. And you all know from math class, that's a positive. I don't think I've seen anybody in any of our classes that doesn't realize these are positive slopes and these are negative slopes. So at this point, let's just go with the negative slope, these points on the graph. Following graph goes with questions 8, 9, and 10. Let's take a look at that. I drew something like this in class the other day. From 20 to 25 seconds, what's the velocity? Well, that's this level point right here. Let's note, it's a distance. This is a time. This distance isn't changing between these two times. That must be a constant velocity. Or excuse me, not just a constant velocity, but it's zero velocity without figuring anything out. From 40 to 50 seconds, well, that's somewhere in here. Here's where we're going to have to do our slope, and we don't get easy points to work with like in the graph we had before. So right here at about, and you're going to have to take a guess on this if we give you this kind of graph. That's 40, that's 60, this is about 50 or 55. I'll call that 55. 55 seconds. It's 800 meters. This is about, so let me go ahead and fill this out. Let me put in a, so I have 800 meters minus, I don't know what, divided by 55 seconds. Minus, I don't know what. So that's this one here. That dot's pretty easy to see. That's 40 seconds and 400 meters. So 400 meters, 55 seconds, 40 seconds. And what we get is 800 minus 400 equals 400 meters. 55 minus 40 is 15 seconds. And what we get is whatever 400 divided by 15 is. It's not 40, it's less than that. Maybe 30. 30 meters per second, about. Plug it into a calculator. Okay, I don't have a calculator. I can show you real easily here. On the graph above, what's occurring from 40 to 50 seconds? From 40 to 50 seconds, well, we just calculated the slope for the velocity. That's just a straight line on our position or our distance versus time. So that has to be a constant velocity. Down here on the graph, what is occurring from 30 seconds to 40 seconds. Here's about 30, there's about 40, and this is the tricky one with this kind of graph. This is not a constant straight line. We'll see something like this. You might have already seen something like this depending on when you're seeing this video. But here I'm going at 0 speed. There I'm going at a higher speed. So between these two, it has to be changing speed. And if it's changing speed, this has to be an acceleration. The units most commonly used for acceleration, you'll hear me call this either meters per second squared, or another one that I tend to use is meters. This isn't showing up too well here. Let's see, home, font, it's no longer superscript. I'll say meters per second, which is really the same thing. The per second says we have seconds times each other in the bottom of this formula. This is a very handy way of thinking about it that will become very handy for our next test and for the work we're going to do in the next week or two. Okay, here's another one. Look at the graph. Velocity over here. Elapsed time over here. What's the acceleration at 2 seconds? On a velocity versus time, the slope of this is our acceleration. So we figure out the slope between 0 seconds and 2 seconds. So it basically took 2 seconds to go up by 1. So this is one where it's going to be half of a meter per second. I guess I didn't get to taking out the multiple choices on these. That's okay. Another velocity versus time. I don't know if we're going to have this many velocity versus time graphs because we spent most of our time on constant velocity. Where is the acceleration equal to 0? Well, just on a velocity versus time, if there's no change in velocity, the acceleration is equal to 0 here, and it's equal to 0 here. Where on this one is the velocity equal to 0. This one is another velocity versus time, and velocity is equal to 0 here, here, and there. This one, you're just reading it off the graph. Remember, for all of these questions, if you understand how to read the graph, you're going to be fine. Okay, last thing I want to do is show you the other review sheet that if you look at that and do that work, you will be massively ready for this test, and you will not have any problem on it at all. So I'm going to do open the computer. I'll go here. I'll open this one, and just very quickly, this one here is also asking you to determine a velocity. This is position versus time. So that's just writing the slope. This one is the mathematical equation to describe the object. Remember what we had to do. It's a straight line, so we can start with the straight line equation, and then we're going to substitute what we were actually measuring, not the y's and the x's. Now, this one says d and t, which is good. Here's a velocity versus time graph, but this is the kind of velocity versus time graph where it's fairly straightforward. Want to know the motion? So this one is a positive velocity here, negative velocity, and a 0 velocity. This one actually asks you to draw the position versus time graph. If you worked on the extra credit thing over the weekend, you have lots of practice doing that. How far did the object travel in the interval t equals 1 second to 2 seconds? And this one is very cool. If you remember what we were talking about, this area actually tells me how far it was. Each of these blocks is equal to 1 meter, because we've got 1 second there, 1 meter per second here. Each of these blocks equals 1 meter, and we can just say 1, 2, 3, 4 meters. What is the total displacement? Oh, so this is going to be a positive 8 meters here. I'm just counting the block. This is a minus 1, 2, 3. So 8 minus 3 is 5 meters for our total displacement. How far did the object travel from 1 second to 2 seconds? We already did that. So that's that. The rest of these questions are just like the one you just saw. I do have a couple of velocity versus times, and these are kind of like the ones you saw a second ago. So if you can get through and answer all these, including these right here, you definitely will not have any problems with this test. So I'm giving you extra credit for working on this, and you can come to me anytime in the afternoon before the test and ask me questions about this. I'd be happy to go over these and answer them with you. If you know this stuff, the test will be really easy. I want everybody to do well, because I think everybody can do well. Okay, that's enough for this video. I know it's been a long one, but I think this hopefully is worth your time. So, take care of yourselves, do well on this test, study hard for it, and may all your problems have solutions.